But first, we are going to go back and answer some dice questions.
Nice.
All right. So, you tossed 2 dice. I want you to find the probability that the sum is not 7. And I want you to find the probability that the sum is more than 4. Okay? 2 different ones. You're going to try it right now. Okay? I left a long list of all the different ways that are possible. Okay? So, the sum is not 7. The probability that the sum is not 7. And then the probability that the sum is more than 4. Okay, what did you guys find? What's the probability that the sum is not 7?
6 over 7.
Yep. And that the sum is more than 4 should be?
Hold on, wait. I'm trying to.
17 over 21.
Because there's 17 different ways for you to get a sum that is more than 4. So 17 out of 20. Okay, we're going to go over a few more card things that we talked about yesterday that I think I might have told you incorrectly.
Oh, man.
Okay. Drawing a spade or drawing an ace. The probability of drawing a spade is 13 out of 52. We agree, right?
Right.
Because it's 1/4 of my deck. Probability of drawing an ace is 4 out of 52, right? Because there are 4 aces in a deck of cards. An ace of spade is common to both events, 1 out of 52. So we're going to take the 2 things and add them together. 13 over 52 plus 4 over 52. But we're going to subtract 1 out of 52. We're going to subtract the one that's common to them both. And we get 16 over 52, or 31% chance of drawing a spade. Or an ace. You've written this down, right? With everything I put up on the board, you should write down. And then we're going to move to independent and dependent events. Are we good? We good? Okay. All right. So, I want you to write this down first. Independent event is when we go A and B. So the probability of A and B is A, probability of A times the probability of B. Okay. And then a spinner is divided into 10 equal regions, numbered 1 through 10. What is the probability that 3 consecutive spins result in perfect squares? What is the probability that 3 consecutive wins result in perfect squares? The equal sign? Like
No.
regions numbered 1 to 10. That word is region. Okay, so remember we have to multiply things together. So how many numbers are a perfect square out of 1 through 10? Just 4 and 9. Okay, so that's 2 out of 10. But I want it 3 times. So that's 2 times 10 times 2 over 10 times 2 over 10. 2 over 10 times 2 over 10 times 2 over 10. Which gives me 8 over 1,000, or 1 over 125, which is 0.8%. Does that make sense? All we're doing is multiplying.
Mm-hmm.
8 over 1,000, so you have to multiply the bottoms too. Gives me 1 over 125.
8 over 1,000.
Is 1 over, yeah, 10 times 10 is 100, times 10 is 1,000. Right? Ready for the next one? For a fundraiser, a class sells 150 raffle tickets for a mall gift certificate. Okay. And 200 raffle tickets for a booklet of movie passes. You buy 5 raffle tickets for each prize. What's the probability you will win both prizes? So if you buy 5 tickets for each, how are you going to set up your probability for just the mall gift certificate? How many tickets were sold? So you should have what over what? Okay. And now you bought 5 tickets for the other one too, and they sold 200, so that should be times 5 over 200, which would give us, we can 20. It'd be 25 over 30,000, but we could reduce that to 1 over 1,200. Okay. Now we're going to talk about dependent. Something is dependent on the other one. Okay? Dependent is we have to do the probability of the first thing times the probability taking away or dividing by the probability of the second. Okay? So our first example. You randomly select 2 cards from a standard deck of 52 cards. What is the probability that the first card is not a heart and the second card is a heart? And we're going to do this 2 ways, independent and dependent. A, you replace the card before selecting it, the second. And B, you do not replace the first card. So you're going to have 2 answers. Do you think they're going to be different or the same? Okay. So try it right now. Try to set that up. Your first card is not a heart, but your second card is. For A, you're replacing. For B. Make sure you're doing both parts. One where you replace it, one where you don't. And what that means.
I feel like for me, you got to know if the first card you picked was a heart.
For B, you'd have to know. What did you say?
Like, you got to know what card you picked the first time. Because if you picked a heart,
So remember, it's what you picked the first time, what the probability is. It's not saying yes, you did it, or no, you didn't.
but like, that would affect what the probability is you picked the second time. Because like, if I pick,
Okay, so let's talk about this, because those are good questions. Alright. For A, I'm replacing it. So what is the probability of choosing not a heart? How many cards are in the deck that aren't hearts? So I'm going to just say 39 out of 52, just so we keep clear that, like we're doing with 52 cards. Okay, so yes, reducing it would be that. All right, now, whatever card we pick, there's 39 out of 52 chance that it's not a heart. Then the second card that we choose, we want to be a heart. So the probability is going to be 13 out of 52, correct? Okay, that's for A. And I get, okay, and I get 3/16. Okay, that's for A. Now for B, I still set it up as 39 out of 52, correct? But then my next one is going to be, where's my piece? Yep, I'll send her in just a second. Yep, there. Okay, the next one is going to be 13 out of 51. So the only things that changed is I kept this card. So the total number of it changed. But I still have, now I think, Ethan, what you're asking is, but what if I didn't choose? What if I did choose a heart?
Yeah.
Wouldn't that change the whole thing? That's not what I'm asking for the probability. I'm not saying I chose a heart and then what's the probability that I choose another.
So like the whole.
It's a probability, right? So if the question said, what's the probability of you choosing a heart and then choosing another heart, that would set it up differently. But yeah, I'm not saying that we chose a heart or didn't choose a heart for this one. I'm saying the probability doesn't change. Okay? So then when I multiply them together, I get 13 over 68. Questions about those? Okay. I'm going to ask you to do another one. Are you ready? Same kind of thing with cards. Alright, I'll just leave you attached. Okay. But now I'm going to say a spade and then a club. A spade and then a club. I want you to do it both ways again. What's the chance of me pulling a spade, replacing it, and then pulling the club? What's the chance of me pulling a spade, keeping it, and then pulling a club? Are you ready? So if I'm replacing the card each time, it's 13 out of 52 times 13 out of 52, which is 116. If I keep it, it's 13 out of 52 times 13 out of 51, which is 169 over 2,652, which reduces to 13 over 204. Yes, Maya.
Oh.
You sure?
No, I'm not sure.
Why don't you ask then?
Yeah, the equation that you put there for the dependent result. You said you had to divide it by it.
So you're getting rid of it. It's more saying get rid of what A was. I believe. Yes. All right. We can start working on our homework now. Make sure when you're reading the homework that you're clear on if they are replacing what you take out or not replacing, because changes.
How do you know?
It'll say right in there.